Good morning. Today we are going to see about the corrosion control. Already we have seen the corrosion control, introduction part of corrosion control. So either we can modify the environment or we can modify the metal, we can control the corrosion. So already you know very well what is corrosion, what are the types of corrosion, especially there are two types of corrosion, one is dry, another one is wet. Wet corrosion is also called as electrochemical corrosion. In the presence of moisture, corrosion will occur. That is, the rust formation will occur on the metal surface is called as wet corrosion. So wet corrosion, either there are two types of wet corrosion. One is galvanic corrosion, another one is electrochemical corrosion. That is a differential aeration corrosion. So galvanic corrosion, two dissimilar metals are contact with each other. One may act as anode, another one may act as cathode. Already we have seen. Second one, when the metal is exposed to the different concentration of oxygen, the less oxygenated area acts as anode, more oxygenated area acts as cathode. So because oxidation is nothing but corrosion. So anodic parts only gets corroded because the oxidation occurs only at anode. So corrosion control, we have seen the one important method is the cathodic protection. In the cathodic protection, the main principle involved in the cathodic protection is to force the metal to behave as the cathode. That means which metals to be protected. That metal behave as a cathode means we can save the metal from the oxidation or corrosion, because the corrosion occurs only at the anode. So the metal to be protected will be acts as the cathode, means it is not affected by corrosion. So that is the basic principle of cathodic protection. So there are two types. One is a sacrificial anodic protection, another one is a impressed current cathodic protection. Already we have seen the sacrificial anodic protection. So some flaws or limitations in the sacrificial anodic protection, it will be completely removed in the impressed current cathodic protection. Because sacrificial anodic protection, some advantages are there. There is power supply is not necessary, but here the power supply is must. And the large scale, large equipments or large manufacturing units or some ships, these are all large structures. These are all not protected by the sacrificial anodic protection, but the impressed current cathodic protection is especially used for the large scale structures can be protected. So here what is the principle of impressed current cathodic protection means? So here the impressed current, that means you have to apply the current. The direct current is applied in the opposite direction of the corrosion current. What is corrosion current? Why it is called as corrosion current? Because there is anode, there is a cathode. In the presence of moisture, moisture acts as an electrolyte. So anode is there, cathode is there, electrolyte is there. Ultimately what will be produced? That is definitely current. So here also the corrosion current, anodic part more, that is the more active metal acts as the anode, less active metal acts as the cathode. So the electronic transformation will occur in the metals if there is anode and cathode means. Moisture is must to move the electrons. So in the presence of moisture it is an electrolyte. So the current is produced, the corrosion will occur at the anode, that is called as corrosion current. So we have to nullify the current. So we have to cancel the corrosion current. We have to apply the direct current in the opposite direction to the corrosion current. Definitely corrosion will be prohibited or it can be removed. So this is the impressed current technique method. That means direct current is applied in the opposite direction to the corrosion current. To cancel the corrosion current is called as impressed current cathodic protection technique. That means we have a battery. It consists of two terminals. One is a positive, another one is a negative. So negative terminal it is called as cathode. Positive terminal is called as anode. So the metal which to be protected, that is connected to the negative terminal of the battery. So that's why what happened, the negative, when it is connected to the negative terminal of the battery, it acts as the cathode. So the positive terminal of the battery is connected to the inner anode. There we have connected sacrificial anode. That means more active metal is connected to the less active metal. So more active metal is anode, less active metal is cathode. So here which metal to be protected, that is connected to the negative terminal of the battery. So the metal, that metal acts as a cathode. We can protect that metal from the corrosion because there is no oxidation occurs at the cathode. So we can protect the metal from the corrosion. But positive terminal of the battery is connected to the inert anode. That means we are not continuous replacement. To avoid the continuous replacement, we can use the inert anode. That inert anode, here the graphite or platinized titanium is used as a inert anode. Graphite, even though it is a non-metal, it acts as a anode because it has a good electrical conductivity. Already we know very well graphite is a conducting material even though it is a non-metal. So graphite or platinized titanium is used as a inert anode. This anode is buried in the backfill. So for example, ship, it is protected from the corrosion. This is connected to any parts of the ship is connected to the negative terminal of the battery. It acts as a cathode, so it is not affected by corrosion. Positive terminal of the battery is connected to the where inert anode. That means inert anode, it is made by either platinized titanium or graphite, which is buried in backfill. Backfill means it consists of gypsum, coke, grease and sodium sulfate. So the backfill, it provides the good electrical contact to the anode. The current from the battery is impressed on the metallic structure. So the metallic structure to be protected because both the impressed current, that means applied current, and corrosion current both are nullified. So we can protect the structure from the corrosion. So it will be protected, it acts as an anode. So this is the impressed current cathodic protection. So applications mainly the large scale structures, large scale units, we can use this impressed current technique, and also but the electricity is must. But sacrificial anodic protection, there is no not necessary to provide electricity, but here large driving voltage is must, and also larger flexibility control. The application is only it's mainly applicable for the large scale projects, and also uncoated parts can also be protected. So the machines parts are complicated parts, it also can be protected by using this impressed current cathodic protection. The limitations means maintenance and installation cost is high compared to that of the sacrificial anodic protection. So this is the corrosion control, that is a cathodic protection. One is sacrificial anodic protection, another one is a impressed current cathodic protection. So we have to apply the electricity in the opposite direction of the corrosion current. We can protect the metal surface from the corrosion. Thank you.